Hey everybody, welcome to H-2, our trigonometry unit, our second lesson on that. We're going to talk about some special right triangles here. The Pythagorean theorem is a wonderful theorem. A squared plus b squared equals c squared. People memorize it. They know that very well. Unfortunately, sometimes it's easier to memorize something than to do the calculation a squared plus b squared equals c squared time and time again. And here's a situation where it makes more sense to sort of memorize the property because we use 45, 45, 90 triangles quite often. And so a 45, 45, 90 triangle is one in which we have two 45-degree angles and a 90-degree angle. If you think of this as a square cut in half through the diagonal, you can throw that half of the square away. We have basically our 45, 45, 90 triangle. And so the two legs would be the same length, because if it was two sides of a square, s and s, the length of the diagonal would be s times radical 2. Now, we can memorize that, or we could use the Pythagorean theorem. So here, let me show you the Pythagorean theorem here. If I did this, it would be s squared plus s squared equals h squared. That would be 2s squared equals h squared. And if we square root both sides, you'd get h equals radical 2s squared, which turns into s times radical 2, which is what we have. So instead of doing this calculation, we just remember that the hypotenuse is s times radical 2. Simple as that. Now the other triangle that is special is one called a 30, 60, 90 triangle. Looks like that. It's got a 30-degree angle, a 60-degree angle, and a right angle. And if we look at that, it basically is half of an equilateral triangle. If we took an equilateral triangle and chopped it right down the middle, this leg would be half as long as this side, because we cut that side right in half. So what would be the length of this leg? So we would set up the Pythagorean theorem again, and we would say x squared plus s squared equals 2s squared. Let's simplify this. That would be 4s squared, but then I would subtract an s squared from both sides, leaving x squared equaling 3s squared. And then I would square root both sides. I'd get x equals s radical 3. And that's the length of that long leg. You've got the short leg s, the hypotenuse, which is 2s, and the long leg, which is s radical 3. And again, we use 30, 60, 90 triangles quite often, and so it's easier almost to, memorize those two properties. And that comes into play quite a bit here. So there's our notes for H2. We're going to look at a couple of examples, and we'll show you what that's like next.